Hello and welcome to the short introduction of position number 14 and 15 inside the Marie Skłodowska-Curie project. At the Technical University of Delft and together with Siemens Gamesa Renewable Energy, we're focusing on the noise generated by atmospheric turbulence, which encounters the leading edge of a large-scale wind turbine. Wind turbines can be placed either offshore or onshore. Whereas for offshore wind turbines, a strong and often constant sea wind enables a continuous energy harvesting, build-up and maintenance are expensive. Onshore wind turbine sites are much more easier to reach, but they have also the sensitive impact on nature and society by, for instance, noise emission. The strong increasing demand on renewable energy forcing also a further extension and development of onshore wind energy. New built or repowered wind turbines with large rotor diameters lead to an improved performance, but goes in hand with an increased noise emission. Therefore, a noise-optimized design and noise mitigation concepts are essential in order to fulfill requirements on emission and increase public awareness. Among all flow-inducted noise sources on modern large-scale wind turbines, the interaction of atmospheric turbulence with the leading edge of the turbine blade is at least understood. For future wind turbine design and the repowering of existing turbines, the physical understanding and the development of reliable prediction method is essential. For the iterative design process of wind turbine blades, fast and accurate noise prediction tools are required. At the current state, analytical and semi-empirical leading-edge noise prediction codes underlying still limitations and uncertainties. Wind tunnel tests are used to picture the flow-surface interaction at the leading edge and help to understand the noise characteristics. The understanding and the description is used to improve analytical prediction models. If inflow noise cannot be reproduced by the actual blade design, so-called add-ons are used to mitigate noise emission. Therefore, the design optimization and noise prediction of those add-ons are further part of the PhD project. Combining research at the university and in industry opens a new perspective to guarantee reliable academic work and simultaneously practical application. Next to the conjunction of industry and university, the Marie Curie training network connects researchers and provides an exchange of knowledge and ideas. The research topics inside the Marie Curie project are diverse. This provides an interdisciplinary exchange and keeps you open-minded.